Chapter 12 starts dealing with probability and statistical possibility, and lesson 12.1 starts off by talking about the counting principle, which I'm actually going to get to later. We will come back to that. We are actually first going to look at independent events. Now, independent events are going to be similar to when I was 13 and I wanted to be independent from my parents and I didn't want to listen. I always said things like, whatever, I do what I want. And I would make sure that whatever they say did not affect me and my choices, because I was going to be separate or do everything separate from what they did. That was me searching for independence. So if we want to look at independent events, things that are not affected by each other, we're going to have examples such as this one, where a sandwich menu offers customers a choice of white, wheat, or rye bread with one spread chosen from butter, mustard, or mayonnaise. So how many different combinations of bread and spread are possible? We're going to actually visually look at this using a tree diagram. Tree diagram basically just means we will map out all the possible outcomes. So we want to look at how many combinations of bread and spread are available. So our bread are white, wheat, or rye. So we'll just put those out here: white, wheat, or rye. Those are our possibilities. And for spread, we could have butter, mustard, or mayonnaise. So we could have white with butter, white with mustard, I'm just going to use MU, and mayo. Those are possibilities if we're using white bread. If we're using wheat bread, we could also have butter, mustard, or mayonnaise. And if we're using rye bread, again, butter, mustard, or mayonnaise are our possible spreads. So it looks like we literally have every single possibility mapped out. We could have white and butter, white and mustard, white and mayo, wheat and butter, wheat and mustard, wheat and mayo, rye and butter, rye and mustard, rye and mayo. So looks like there are a possibility of 1, 2, 3, 4, 5, 6, 7, 8, 9 total combinations. So there are 9 possible combinations of bread and spread. Let's look at another similar example using independent events. It says for their vacation, the Murray family is choosing a trip to either the beach or to the mountains. So those are the 2 possible destinations. They can select their transportation from a car, plane, or train. How many different ways can they select a destination followed by a means of transportation? So we'll use a tree diagram again to show that their destination would be either the beach or the mountains. So we'd have beach, we'd have mountains, and again their transportation is either car, plane, or train. So we could have car, plane, or train. While going to the beach or going to the mountains, we can have car, plane, or train. So again, it looks like there's a total of 1, 2, 3, 4, 5, 6 different combinations of destination and transportation. So in this case, we'd say there are 6 total. What if there are more than 2 independent events? Well, in this case, we'll start off by just looking at 2. So we're at just 2 independent events. So it says how many codes are possible if the code is just 2 digits. Actually, I'm going to say 2. So there are 2 different places where we can put in numbers. And remember, digits or numbers go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are actually a total of 10 possible quote-unquote digits. So instead of doing a tree diagram, we're going to use an exhaustive diagram. We'll just write it all out in kind of an array. So we'd say that there's 0, 0, or 0, 1, 0, 2, all the way down, looking at all of the codes that start with a 0. 0, 7, 0, 8, and 0, 9. So all the codes that start with 0 would look like this. What if our code started with 1 though? So we could have 1, 0, 11, 12, all the way down to 19. Now instead of writing all of these out, the little ellipse, dot, 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 say that we go all the way to 90, 91, 92, and all the way down, oops, 95, 96, 97, 98, and 99. So this would contain all the possible outcomes or the possible codes if we just had 2 digits. Now in this first digit place, that can vary, remember, from 0 to 9. That would be like this first digit, this first digit, this first digit, varying from 1 to 9. Looks like there are actually going to be 10 different possibilities to range our first digit. For the second digit, the second place, that would be if this changed all the way down 0 through 9. So again, there are 10 possibilities on this side. And if you remember, viewing this like an array or like a graph, it looks like this is a 10 by 10 square then. There are 10 different possibilities going across and 10 going up and down vertical. Now how many places then are there? They're 10 by 10. We would actually say that there are 100. And we got that by saying 10 possible going across and 10 possible going up and down. 10 times 10 is 100. So there are 100 spots, different codes, 100 different possible combinations of 2 digits. And again, we got that by multiplying 10 by 10. Now, is that going to work in all cases? Actually, it will. Let's go back to the fundamental counting principle. That says to find the total number of possible outcomes, you multiply the number of outcomes for each event. So, in our case, like I said, there were 10 in the first digit and 10 in the second digit, so we got 100. And that's how we found 100 possible outcomes. So let's check our other ones to see if the fundamental counting principle holds. If we look at how many bread choices we had possible, white, wheat, or rye, there were 3. And how many spread choices do we have? Butter, mustard, or mayo? There are also 3. 3 times 3 then is 9 possible solutions. And we said, 9. So we got exactly the same whether we looked at a tree diagram or whether we used the fundamental counting principle. Let's check one more time here. Our destinations were beach and the mountains. So it looks like there were only 2 possible destinations. And there were car, plane, and train. So 3 possible transportation modes. 2 times 3 is 6 is our possible outcomes or combinations using the fundamental counting principle. And 6 is how much we got visually looking at a tree diagram. So again, fundamental counting principle holds. So now we're going to get to an example when there are more than 2. In this case, we're looking at 3 digits, a code of 3 digits. So if there are 3 of them, 1, 2, 3, and because they are digits, remember that's 0 through 9, so there are 10 possible. So there could be 10 right here, 10 different ones right here, or 10 different ones right here. So if we multiply those together, 10 times 10 times 10 is actually going to be 1,000. So there are 1,000 possible combinations of 3 different codes using the numbers 1 through 9. So I know this one isn't written on there, but just for kicks, I wonder how many different phone numbers there are possible. If we look at the area code, which is going to have 3 digits, the first 3 digits of your number, and then the last 4. So all phone numbers are normally written in a 10-digit format. It goes area, dash, first 3 digits, dash, last 3 digits. So again, because they are all digits going 1 through 9, our area code could have 10 here, 10 here, and 10 here. The area code around here is normally 507. So that is one possible area code. Then the first 3 digits possible, again, there are 10, 10, and 10. So like 536 or 277. Those would be the first 3 of your phone number. And then the last 4, again, there are 10 possible here, here, and here. So there are 10 possible digits in each of these spots. And there are 1, 2, 3, somebody use red here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible spots. So there are 10 combinations possible to the 10th power. Again, we could just write it as 10 times 10 times 10 times 10 times 10 all the way across to the end, or we could write it as 10 to the 10th, which actually in the end equals 10 billion. So there are 10 billion different possible outcomes or different possible phone numbers available to you. So I'm pretty sure you don't have to worry about somebody accidentally having your phone number, because there are 10 billion possible.